Everyone, here we're going to be working through the next steps in solving a multiplication rule of probability problem. So we've gone through previously identifying the language that you're looking at the probability of A and B, and we've gone through what that looks like when you're looking at your formula and translating that out to the actual description of what you're doing. We've also looked at determining if the events are independent or dependent. So now we're going to move into doing the formula solution, and we're going to do a couple of practice problems. So, the first thing we need to be looking at is deciding which formula to use here. So, I've provided you with a nice little flowchart for making your decisions. I suggest you add this into your notes. Again, this is another place where trying to memorize everything isn't going to benefit you. What you really want to do is pay attention to getting an organized pathway that you can use to help you decide how to solve a problem. So here we are doing a probability of A and B, so we know we're using the multiplication rule. And then we need to look at whether or not A and B are independent events. If the events are independent, then we're going to use this formula over to the left. And here we can see for solving that is simply going to be probability of A times probability of B. Since one is not affecting the other, we have a pretty simple calculation here. However, if A and B are dependent events, then we're going to use the formula to the right, and this gets a little bit more complex. As we can see, we're going to be using our probability of A times the probability of B given that A has already occurred. So that's a slightly more complex formula. So make sure when you're looking at whether your events are independent or dependent, make sure you're using the right formula and that you're not making things harder for yourself than you need to. Okay, let's get into doing a practice problem. So this is number 14 from your book on page 165. We are once again working with our pre-employment drug screening results. And here we have got the idea that we are taking 3 of the 1,000 test subjects and we are randomly selecting them. And we want to find the probability that they all had false negative results. Now, we've got 2 different ways we're solving this problem. Part A, we're assuming that the 3 selections were made with replacement. Part B, we're assuming the 3 selections were made without replacement. So we're going to solve both problems here as we go through. So how do we get started with this type of question? Where do we even begin? If you're feeling a little overwhelmed, let's take this through one step at a time. So the first thing you need to do is identify each of the probabilities that we're solving for. We're solving for 3 probabilities. Using the probability notation, these are going to be P of F1, false negative result for the first selection. And notice I've used F here to represent false negative. You could use anything you wanted to, but you do need to designate for yourself what your F is representing. So then we have P of F2, which is the false negative result in the second selection, and P of F3, the false negative result in the third selection. So these are the 3 probabilities that we're looking at. So before you get going, again, adding numbers in and starting to do your formulas, the first step is identifying what you're solving for and getting your notation correct. Now let's apply our flowchart that we have for our problem. So here's our flowchart, and we're looking at these different events. All right, so are these events here in A independent or dependent? Hint, pay attention to the bolded part that these selections are made with replacement. So, what type of event is this? Is this an independent or a dependent event? Because the sampling is done with replacement, these 3 selections are independent events. And so using our flowchart, we can see that we are going to use this formula right here. We have the arrow pointing to it here on the left, right? So we're going to use the probability of A times the probability of B. And in our particular situation, since we've got 3 selections, we're also going to add in a probability of C. All right, so let's look at how this alteration works in conjunction with our basic probability formula that we've been working with already. So here we have our data, and we have our formula of P of A equals the number of ways A can occur divided by the number of different simple events. So applying this into our formula, we can see that we have 6 false negatives. So that's the 6 different ways that A can occur for this particular problem for our first selection. And the number of different simple events are simply all the individuals that are part of this particular drug screening results outcome. And so we simply take all of our numbers, 44 at plus 6, plus 90, plus 860, and we get 1,000 for our total number of different simple events. Plugging these into our formula, we get 6 divided by 1,000, which gives us a probability for F1 of 0.006. Okay, now since we've solved that one together, take a few moments, pause the video, go through and solve for P of F2 and P of F3 yourself. Once you've got those solutions, turn the video back on and move to the next screen so we can check your results together. Alright, you should have had here your P of F2 is going to be 0.006 again, because we haven't changed anything here. These are independent events. And we've got, as we go through here, our P of F3 at also with 6 divided by 1,000. Now our last step is to go through and multiply them together. Thus the multiplication rule of probability. So we're going to take these, multiply them each by the other, and we should get 0.00000022. This is the solution for part A of exercise 14. Now let's move on and look at part B. So here we've got part B. Again, we're going to apply our flowchart to the second part of this problem. And we need to go through and decide if these events are independent or dependent. As a hint, notice that these selections are made without replacement. Since these selections are made without replacement, that means that these 3 selections are dependent events. As I've made a selection and I did not return that individual back to the original 1,000, that has now changed the probability. So we're going to be using this formula here on the far right. So we can see here we're going to be using our probability of A times our probability of B following A. And again, because we've got 3 events, we're going to have a third component, which is going to be probability of C, given that probability of A has occurred. So let's go through and look at how we apply this to our actual data. Okay, since P of F1 still occurs first, the probability formula for this event is the same as we used. So it's going to look just like this. All right, that part does not change. However, now that we've selected one subject and we're not putting them back in, this changes our count. So, because the subject was selected was a false negative, this changes both our total count of total number of possible simple events. So, instead of 1,000, we have 1,000 minus 1, so that's 999. It's also going to change the number of ways that another false negative can occur. So again, one of the people we pulled out was a false negative. So in this instance, we're going to have 6 minus 1, which is going to give us 5. Now let's go plug these in to our formula. So we get 5 divided by 999. Okay. Now you want to go through and solve the same problem yourself for P of F3 following F2. And when you're done with that, move on to the next slide and we'll check the answers together. Alright, so you should have had for P of F3 following F2, you would have had 4 divided by 998. So going through and doing the division for each of these, we get 0.006 times 0.005 times 0.004. Again, we're multiplying all of them together. So what does that give us for our final answer here? It should give you 0.00000012, which as you can see is a different probability than for part A. So notice what's important here is when we were making the sample selections with replacement, we got one probability. Then we were making the selections made without replacement, we got a very different probability. So pause here, make sure you understand, and have these components matching with what you have in your notes. Once you've got that all lined up, we'll be ready for the next section.